Okay, so I would like to remind you all of shifting rules. Do you all recall shifting rules in any meaningful way?
Yep.
Can you tell me things about shifting rules?
Well, you can shift things to the left, and you can shift things to the right, and you can shift things down, you can shift things up.
Okay, so that sounds like I need to, at the very least, write something about left, right,
And of course, you can shift things, diagonally
up,
too, but
and down,
stick it in mixed directions.
and mixed
Yeah,
at
in
least.
mixed directions.
Okay, so if you, for instance, wanted to shift the graph of a function f left,
Yeah.
how would you do that?
X, add x's, add some x's.
It's like the opposite.
So you do like x plus a constant,
Yep.
and
And
then
x plus a constant.
this would be your f.
Your function, yeah, if you add something to the end of your function, you're going to shift it to the left.
No.
Oh,
That was shifted. That was shifted.
Okay,
That was
so-
shifted up. That was shifted up.
Hang on. I think I need an idea. So let me play with an example.
Oh, that's
Negative.
So let me look at f of x is, say, x squared.
all right. Your family problem.
Okay.
I don't know.
This is a parabola.
Yeah.
This parabola, specifically.
Plus 3.
That one is x squared specifically.
Okay.
Okay. So
Okay. Add two
when you
parallels.
see this thing, I want you to think parabola.
Agreed.
Okay?
Yeah.
Okay. So let's figure out how to, what did you want to do? You wanted to add the constant afterwards?
If we added the constant after, if we added 2, it would go up on the y-axis 2.
So let's try that. So if we do maybe fu of x
Fu of x.
is x squared plus, say, 3.
Yes.
That's your kind of thought?
Yes.
And your claim is that this should go up.
3 units.
So can you explain me why this should go up?
because oh, go ahead.
Change the plug in 0. But just mathematically speaking, if you plug in 0, it y will move up 3.
Okay, so definitely if I plug 0 in, I get 3 out. I'm down with that. You have thus far convinced me that I should have this dot
And-
here at 3 high.
Cool.
I am at least convinced of that.
And therefore, the end, then the.
So how do you know it didn't go like right 2 and up 1 instead?
Uh-huh.
Is it-
I didn't know it didn't go right 2 and up 1. Why would you do
I don't know, it could have done that. Math is weird. It's just a bunch of friggin' rules
Oh,
that
I
some
see.
asshat
I see.
made me memorize.
Okay, I see.
I mean, it's a real number.
Right?
Whenever you plug in an input, there's always an account to add 3 to your outcome.
Yeah.
That's what I want to hear. I want to hear you guys think, okay, when the way you do this function fu, right, is first you do f, right? And then you're kind of sitting in the land of outputs for f, right? And you're going to slap a +3 on the output for f.
Mhm.
So that's only going to move it in the output direction, and it's going to move it up 3 in the output direction. Well, it's going to move it +3 in the output direction,
Yes, +3.
right? Okay, parabola. That's fu. Cool?
Yes.
Okay, so I think we established that the way up works is add a positive number, maybe a positive constant, after doing the function. You guys kind of with me on that?
Yeah.
Okay, how would you get something to go down?
Well, you subtract.
Yeah, subtracting seems like it would send things down. So you would
Add a
add a negative constant or subtract a positive constant. I don't care how you phrase this, but it's only one or the other. Subtracting a negative constant will
We'll add a positive.
add a positive constant with you up, right? So I'm gonna write add a negative constant because that's where I feel like you guys are at in life. And that again has to happen after doing a function. Why does it matter that it's after doing a function?
Because you don't,
You guys get a Somebody else? Why does it matter that I'm doing this after the function?
Because it's moving the whole function at once.
Kinda. I want it to move strictly in the which direction?
Along the y-axis.
Yeah, I want it to move strictly in the y direction, right? So I want to have gotten rid of my x's before I do this adding thing, or subtracting. You guys see that? So once you've turned your x's into y's, the only direction you have available to you now is the y direction. You guys kind of with me on that? Okay, so how about left and right?
I feel like
What's your,
if you put them in parentheses, if you put,
like multiply.
okay,
I
hang
feel
on.
like it should be slow.
So,
You should be able to plug in something like 3 and then get
It's like
0.
f of x or f of whatever l. Is that
okay, I'm going to do FL of x.
Okay. Equals.
And I want to try to accomplish go left.
I want to go left, and I want to go left 3.
X
Okay.
parenthesis x minus 3 parenthesis.
X, parenthesis, x minus 3, parenthesis.
Yeah, I'm gonna stick with that. That's my. Let's do that.
Okay.
So let's say you plug in 3.
So if we plug 3 in, we get 0 out.
Yeah, which is what we want.
That's kind of cool. So far you've convinced me that there should be a dot over here at -3.
So let's plug in 4.
Hang on. What's another thing you could plug in there?
0.
0? What do you get out?
Oh.
Zero.
You get
Oh.
So that's
Damn.
Right? So this one went not just left, but kind of left and down.
Okay.
Right? And why did that happen?
What happened?
I think it happened because I did something to some of the x's and not to others, right?
Yeah.
I thought about x squared as like, oh, there's 2 x's there. I'll add 3 to one of them. Like, how would I do that rule consistent? You guys see that? Like, you had sine of x. Did you add 3 to the only x that's there? What if it was x sine x? Okay. Anyway, trust me. Good idea about the -3. Not so perfect
Would
on
you
where it
do,
went.
the x minus 3 like quantity of that squared?
That seems like a good idea. Why do I think that's a better idea?
Because you're doing it to both the x's.
Right now-
Because at least I'm doing it to all the x's consistent. You guys see that? So, how do I know that went left 3 though?
Because it's squared.
Because it's negative.
I don't think.
Oh.
Ryan just
Maybe.
reminded me
I think
that
if I plug +3 in there,
Oh,
what do I get?
Zero.
If you plug in +3.
If I plug in +3,
It's zero.
I screwed up my sign on the other one, didn't I? You guys see that?
Yeah.
So the other one was over here anyway. My bad.
So we should do positive.
So we should do +3, I think, to get it to go left 3.
Yeah.
So now when you plug in -3, it's 0.
Yeah.
Yeah, you guys with that?
Yeah.
Like, why does that seem backwards?
Because it is.
Because it is. Yeah, that one's unfortunate. So it should be noted, one of the caveats to shifting rules, the primary thing you should take away from this lecture is there is no justice in the world.
Until it's my poli sci teacher.
Yeah, you can tell them that's a mathematical truth.
Yeah.
There is actually no justice in the world. If there was, adding 3 would shift right, just like adding 3 shifts up. You guys with that?
Yeah.
So what you have to remember is that the x stuff is backwards.
Uh-huh.
And that is actually fundamentally true in a bunch of different ways. So as long as you remember that input stuff is backwards, we're okay.
Okay.
Okay? So left 3, or left in general, I would add a positive number, or a positive constant. Yeah, before doing the function. Okay, so there are two pieces there, right? That adding a positive constant, the positive is telling you which direction you're going to go, right? And the before is telling you in which axis you're going to go in that direction.
Okay.
You guys see that?
Yeah. So
Okay.
if I wanted to shift and if I'm to shift left and move up, would you just like add 3 to the quantity of x plus 3 squared?
Okay, so
X plus 3 squared plus
if we wanted to say go, where do you want to go? You want to go
Up 3 and left.
up 3 and left 3?
Yeah.
That's going to be confusing. I'm going to go up 3 and left 2, so at least they're different.
Cool.
Okay, so if I want to go up 3 and left 2,
So you do
what do I need to do? This up 3, that's a
plus 3
Plus
after.
Plus 3 outside.
plus 3 after,
yes.
and the left 2 is a
Plus 2.
plus 2 before.
So do
Okay, so hang on. A good thought is to just bubble diagram these. So I think I need 3 steps, right?
Mhm.
So what's your first step? What's the thing happening before?
You're gonna add 2
You're going to add 2 beforehand,
and then you're gonna square.
and then you're going to do the rule, right? You're squaring. That's the thing that gives you your shape, right?
Yeah.
And then what's your next one?
Add 3.
Add 3. That's cool then?
Yeah.
If you watch other of my videos where I'm talking about shifting rules, I'll usually do something like this. That's the thing that's giving you your shape, right? So think parabola. This before the rule, add 2, that's a left 2. This guy, that's a
Up 3.
up 3. And that's usually how I'll graph shifted functions. So if I want to think about how to graph this, I just go left 2, up 3, dot parabola.
Whoa.
You guys kind of with me on that?
Parabolas.
How would you do right?
Well, you subtract.
Add a negative constant.
Add a negative constant. Before doing the rule. Or doing the function. Cool?
Cool.
Okay. Do you guys remember any other shifting rules that I should have?
What about like growth, like the separation?
Flipping.
Oh, flipping! Flipping's fun. Let's do flipping. Also, keep in mind, there's nothing special about the parabola, right? These rules work for whatever function you put into them. So if you want to use these with sines and cosines, it works the exact same way. It gets confusing with sines and cosines. Why does it get confusing with sines and cosines?
Because you're adding and subtracting like radians.
Yeah, because you're adding and subtracting things with pies in them,
And
and
name
they're periodic, right?
Yeah.
So sometimes adding an amount and subtracting a different amount are the same
it.
thing.
Yeah.
That gets confusing.
Plus they call them like different things,
Plus they call them different.
like amplitude, right?
Oh, yeah.
Yeah.
I'm going to ignore that. Okay, so let's talk about flips. There are 2 kinds of flips.
Like back flip and front flip.
Exactly, a back flip and a front. Actually, they're more like a front flip and a side flip, but whatever. So they're over the x-axis and over the y-axis.
And over the x equals y axis.
That one's for inverse functions,
Right.
so that's not one.
Oh.
Because that makes a different function.
Fair enough.
These are for this. These are kind of flipping the same function.
Okay.
Yeah. Ish. These are what are called symmetries, and that one's weird.
Okay.
Okay, so if I want to flip over the x-axis, what's that going to look like? It's going to look like this, right? So if you want to flip over the x-axis, which thing are you changing? Are you changing an x or a y when you're doing this?
Y.
changing a y. What are you doing to the y's?
Do negative.
Negativizing them.
Yeah, negative.
Good. So how would you negativize a y?
You negativize a y by making it negative.
Yeah, so you need to, one, get a y first, right? So how do you get a y?
You find an x and then associate it with a specific y.
Yeah, okay, so you do the function, right? And then you want to multiply by
Negative
-1.
y.
So over the x-axis is going to be multiply by -1. Why would I write -1 after the rule? You guys see that? That's going to do this thing. Okay? What if you want to flip the other way, this way, over the y-axis?
Logic would tell me that I
Y
should
by
make
-1 before the rule?
I feel like you shouldn't do that.
Is this a y thing?
It's an x thing.
It's an x thing, right?
Yeah.
So I'm totally with you otherwise. I want to multiply by -1 before the rule. And the thing I'm multiplying by -1 is going to be the x,
Yeah.
right? Because I'm still before the rule.
Over the y-axis and change your axis.
Oh, yeah, your x is, it's different.
Yeah.
Opposite,
Yeah,
yeah,
exactly.
opposite x.
That's why we're saying negative.
Okay,
Right,
So-
right.
I need to give you a couple more words. There's special words about flips. Well, there are special functions that aren't affected by flips. How about that? So what if I did an example where I said, okay, flip x squared over the y-axis.
Oh, that's silly. It would be the same thing. Yeah, same
It would be the same thing, right?
And
You
then
would
you
do
have
like,
to-
okay, so if I think of this as f of x, right? Then g of x would be f done to minus x, right?
Which is just x squared.
But f is just stuff squared. So if you take minus x and square it,
It's the same as positive x.
you just get positive x out anyway.
Yeah.
Okay, this kind of motivates me to write a definition. What's the word I'm defining? Anybody know?
You're defining symmetry.
Close.
You're defining
I'm defining a special kind of symmetry for functions.
linear symmetry, perfect symmetry,
Yeah.
Y symmetry.
You're throwing behavior.
Defining a
Vertical
function is
symmetry.
Absolute.
Absolute symmetry. Also absolute values no.
Absolute values are another example of
Exponential
this.
symmetry. Evolutionary symmetry.
A function is said to be even
Even.
if f of x equals f of minus x.
Absolute.
I guess, suppose I should say a function f of x is said to be even
Okay.
if
Odd.
f of x is f of minus x. In other words, it acts like an even-powered monomial.
Okay.
You guys see that? Like x squared is one of these. X to the fourth is one of these. In other words, these are similar over the
Y.
y-axis. So what's the other definition that should go with this?
Odd.
A function
Is odd.
f of x is odd
Flipped over the x.
if, yeah, exactly. If you flip it over the x-axis and it's the same. How do you flip it over the x-axis?
You make the you multiply by -1 after the rule.
You multiply by -1 after the rule and get the same thing. So you should say, this is the same thing. This is the thing you started with, right? Is
Negative f.
negative f of x. Very nice. You guys see that?
See.
So, question. Does anybody recall a trig function that's even?
No
Damn.
idea. I just had the first thing that came to my head. Okay, trig function that's actually even. Oh, tangent. Right? Because it flips over the y. It's at the origin. It's symmetric. Oh no, it's opposite. Never mind.
Cotangent.
Tangent's odd, sine's odd,
Yeah, cosine is odd.
cosine is even.
Oh, why am I so bad at that?
I don't know even. I don't know.
Yeah, it starts at the
Okay,
highest
so
maximum.
this is what I want you to know for trig functions to start with. Or sorry, for shifting rules to start with. Move things up, down, left, and right, and flip them over both axes. Cool? Also recall there is no justice in the world.
No justice is in the world.
Yeah, and today for your quiz, I want your 3D printing draft.